Do you see my presentation?
Yes.
Okay, then we can start.
Good.
Good evening, everybody. Actually, my name is Artsem Prashkovic, and I'm going to start with short introduction of myself. Actually, I have more than 10 years programming experience. Since April 2012, I work for Brimit. I have more than 8 years experience in Sitecore, and I'm Sitecore Technology MVP since 2018. And currently, I'm located in Minsk, Belarus. And there are opinions that GSS is mostly used for simple websites or single-page applications. Today, I will share how our team uses GSS, React, Akamai, and Uniform for creating a website with millions of users for tourism agency. First of all, a disclaimer: as long as our customer is a national tourism organization, so we have an NDA, and uh, it doesn't allow it doesn't allow us to share the customer name and some project details. The second one, I'm not a front-end developer, and I'm not a React developer, and probably I will not be able to answer a specific front-end related questions, but I can try at least. GSS was announced a few years ago, and I think many of us know what is it and how it looks like. But anyway, I will say a few general words about it. GSS or JavaScript services is a toolkit for JavaScript developers, allowing to build full-fledged customer solutions like single-page applications, web apps, websites, using modern JavaScript libraries and frameworks, React or Angular, and be completely unplugged from Sitecore. As we can see on diagram, GSS is based on such services as layout, content, dictionary services. There is also import service, and I separated it because it doesn't take part in rendering process. In case using code-first approach, this service is used for deploying changes to Sitecore. We also can see config file where GSS app is defined in Sitecore. There are also a Node.js server and Node.js view engine, which are used for rendering components based on the data, which is provided by layout service. The view engine is used when rendering is performed on Sitecore side rather than on Node.js server side. But take into account that in both cases, the data come from layout service, data for rendering. Okay. As we know, Sitecore 10 was released not so long ago. There are not many new GSS features with this release. The changes are mostly related to improved stability and support for new platform features. The image represents Sitecore 10 architecture. We can still see the same services as layout service, dictionary, import service, and GraphQL. Sitecore connected all these services in separate module called Sitecore headless services. And this module, previously known as Sitecore JavaScript Services Server, provides the server-side APIs and components which are required for ASP.NET Core Rendering SDK, the new one, and for JavaScript Rendering SDK, previously JSS. Now is the time to switch to the main point of presentation, sharing my experience of using GSS on a real project which is currently in production. A few words about our client. The customer had a platform built using Sitecore 7 and was looking to build a new one using Sitecore 9, while Sitecore is used as a headless CMS. It was also planned to integrate the new platform with selected marketing technologies in their digital experience platform. The scope of the project includes migrating content, keeping the existing custom integrations and extensions from the old platform. The new platform includes 4 sites with separate sitemaps under the separate domains. Each site will have new design following the modular approach. One of the requirements of the project is a time to interactive should be less than 1 second. The TTI metric measures the time a page takes before the user can interact with it, or in other words, how long before browser responds to the click. Almost all architectural decisions are made around this requirement. I will call it the main requirement during the presentation. Now I want to say about our architecture, server infrastructure, and first of all, I want to say that all our deployments is automated. We use the Azure DevOps for make our deployments, and the actual server architecture consists of 3 groups: QA, UAT, and production. Currently on the screen, we can see our QA environment. Here, 2 CM servers and load balancer between them. We have 2 CM servers because we load 1 CM server with some scheduled tasks like integration. We have some integrations that require some loading time, and another case is to make it high availability, to keep high availability for CM servers as well. Then we have 2 publishing servers. We find out one interesting thing, that the publishing service is scaling up automatically. They both use the same publishing queue and process the items from the queue together. Also, we have a backend identity server, which represents the default Sitecore identity server, which goes with out of the box. And we have the Solr search server, which is connected to CM server only. We don't use the Solr on our delivery servers at all. We have Azure directory connected to the CM server as well. Now we can see our UAT environment. It is pretty the same with the QA, but here we have green content delivery server and blue. We utilize the blue-green deployments for UAT and for production environments, and there is 2 groups, and then this is only one difference between our QA and UAT environments. And finally, it is our production environment. The CM content management group is pretty the same for all of this, for all of us environments, and here we can see that we have 2 groups of CD servers. We have green group and blue group, and load balancer between them, but this one load balancer is not really it's not really original load balancer. It is I will say a bit more about this load balancer, but actually this load balancer is represented by Akamai. I was thinking a lot of what to show on this slide, but our backend part is pretty much conventional and Helix-based solution. Integrations, helpers, basic stuff for features represent the foundational layer as usual. Each module in Sitecore represents a feature in solution. A feature always includes a unicorn configuration. It also can optionally have rendering content resolver if component requires a custom one. configs, and other Sitecore related code for preparing data for the view. I will add more details about most global issues and how we solve them a bit later. Before switching to the front-end solution architecture, I want to go through the definition of code-first and Sitecore-first approaches. As you probably already know, Sitecore JavaScript services has two approaches to work with. It is code-first and Sitecore-first, and in case of using the code-first approach, front-end developers work disconnected from Sitecore and define Sitecore structure via in-code component definitions and root data. Sitecore information architecture is generated via the import process, and this approach is recommended for smaller projects or temporary sites like campaigns. Front-end led projects or micro apps within the large site. And in case of using Sitecore-first approach, Sitecore information architecture are created by Sitecore developers, no import process utilized. Front-end developers works disconnected from Sitecore and creates components and mock root data based on the contract provided by Sitecore developers. Contract can be defined first to allow concurrent work, and this approach is recommended for complex projects and organizations which looking for full control over Sitecore information architecture. Our project is complex. We are definitely looking for full control over the Sitecore information architecture, and so Sitecore first approach is an obvious choice in our case. Now the time is speak about Sitecore information architecture, and utilizing a Sitecore first approach, we have a full control across Sitecore information architecture. It allows us to have a content structure we want, any number of page templates with a preset presentation on standard values, branches with default data sources. From the Sitecore perspective, it looks pretty standard, and nothing says that it is a headless solution. Our Sitecore solution represents a multi-site solution and multi-language. Actually, we have 4 sites here. We can see that we have a lot of different page types. So everything looks like standard Sitecore solution. We also built our Sitecore solution based on the Helix principles, and each site is a project. Module which can contain more than one component or rendering is the feature layer, and base templates, data models, integrations, workflows, global settings is a foundations layer. Only one thing which is different from standard Sitecore application is all renderings utilized created based on the JSON renderings template. One more thing, that we have the global data where we have articles, events, itineraries, POIs. So this kind of data is some main data on our project. The items under these folders represent the pages. It is item with presentation setup, and these items can be reused on probably almost each site. Come on. React solution architecture. We built a slightly different React solution compared to a standard GSS. We did it because we have 4 different websites. Some of them have a different layout. We implemented about 150 components. At least half of them are shared and used for each website. The rest of them are website specific. To avoid any component duplication, we separated component implementation and the GSS apps. Eventually, we have UI components React project, which contains all components, implementation for all components. We have Site1 GSS app or React. It's React project separate. It is very similar to the original GSS React app, but has only one difference. It doesn't have a component implementation. Components are included to the app as an npm dependency. And we have the shared project, which is common for site 1, or sorry, for site 2, site 3, and site 4 on the previous diagram. UI components project has two build commands. One for shared GSS app. The difference is in number of components that will be included into the package. Each of them includes only the components that are required for the specific site. After the build is complete, the code is pushed to the private Azure npm repository. Then, when we build the shared app, it downloads the corresponding package from the repository with the package with components. This is really helpful because we have to take care of each byte of assets to meet our main requirement again. So when we will prepare artifacts for the shared GSS app, it will include the stuff in orange area. When we will deploy or build the site 1, it will include shared components and components which is related only for the site 1. We have shared GSS app because 3 of our sites has the same layout and they just use the same components, just each site has different color theme. So the next thing that I want to say is Content Delivery Network or CDN. In our case, we use Akamai, and Akamai is a cache. Cache is most important part in trying to meet our main requirement. Akamai is a leading cloud-based CDN service provider for media and software delivery. All of our websites are fully cached by Akamai. I found Akamai to be a powerful tool that, in addition to caching, can manage the traffic routes, can be used as a load balancer, can rewrite URLs, perform personalization, and a lot of other things. Akamai help us to implement blue-green deployments. At the beginning of UITU production deployment, we force Akamai to route all traffic to the green group using PowerShell command and start deployment, and then we start deploying to the blue group. Once it is deployed, we are able to verify that everything is fine, and then we route traffic to the currently deployed blue group and start deploy to the green group. At the end, we force Akamai to route traffic to both groups, and in this case, we have 0 downtime during our deployments. Traditionally, only static content can be cached on Akamai when it is used with Sitecore. Caching images, scripts, and other static files can improve site performance by decreasing the load time on the Sitecore content delivery server, but a lot of work still remains for the CD server. Any part of website that uses personalization must be handled by the CD server. This approach appears to be simple. The visitor connects to the Sitecore instance. Sitecore builds the page. Sitecore returns page to the visitor. The problem is that puts a huge load on the Sitecore instance. So then you have start to scaling up or scaling down your environments. It also means that you cannot take a full advantage of CDN. Science personalization has to run on the Sitecore instance. The CDN use is limited to delivering images and other static assets only. But again, to meet our main requirement, we have to cache HTML as well and cache all requests to the server. Another our requirement is to be able to personalize components, and taking into account that Akamai can run personalization on edge, customers decided to utilize Uniform to connect Sitecore personalization with Akamai. A few words about Uniform. And Uniform connects Sitecore to the modern developer tools and leading CDNs. This means new sites can be developed using a Jamstack approach, connecting leading static site generation to Sitecore MVC or GSS sites and deployed to the CDN of choice. For fastest performance, resilience, and global scale, Uniform moves the execution of personalization rules from CD server to Akamai. Since Akamai can deliver content to visitors much faster than properly turned up and scaled up Sitecore architecture, you end up with the fastest possible personalized Sitecore sites. To understand how it works, consider that the two things that happen when Akamai receives a request. The request is for the page that is not currently cached, called a cache miss, or the request is for page that is currently cached, cache hit. So in case when we have when our page is not cached, Akamai must make a call to the Sitecore instance. This does slow things down, but since the personalization does not run on Sitecore instance, Sitecore is able to handle the response faster than in case of personalization response. Let's look to the diagram. So we can see the visitor do a request to the Akamai. Akamai check if page is cached or not. And in our case, it is not. Akamai does request to the Sitecore CD server. In the same time, Sitecore requires the personalization rules from Akamai and get it from Uniform. And the responses represent the ECI rules. Then Sitecore build the page, responded to Akamai. Akamai put data to the cache, resolve context, and run personalization. Once it is done, Akamai responds page to the visitor. Here you can see the example of ECI tags. There is pretty simple example. We have some condition. If it's true, the Akamai will do a new request for the data, or maybe for also here can be some HTML snippet or any other data between the tags, ECI tags. It's so slow. Come on. Some problems with my presentation. It freezed. Come on. Okay. Sorry. And when Akamai has a cache for the page, this is where things get interesting, because This time Akamai has everything it needs to handle the request. It does not need to make a call to the Sitecore instance. The result is the fastest possible performance for our pages. In pursuit of reducing a number of server requests, we made a decision to utilize the Algolia search. The Algolia provides search as a service, offering web search across the client's website using an externally hosted search engine. Algolia provides a very useful APIs. It can be used with React, and we have a full control over the items which need to be sent to Algolia. So as you can previously, we have a different type of data, such as events, articles, POIs. We have a lot of dynamics components that show this data. All components get data to show from search engine based on text selected in data sources. Let's have a look at the diagram. I will explain how it works. Once authors make any content changes and push them and publish these changes, it gets to the web database. Once database is updated, these changes goes to the web index and keeps here. On one CM server, we have a scheduled task which is run every 30 minutes and get latest updated items from the index, process them and push to the Algolia. Then, when GSS renders a page, it requests a JSON from the layout service. So on our web app, we have, let's say, some static components like banner, CTA, or map, and JSON from layout service includes everything what these components need to be rendered. But so this is the static components. But we also have some dynamics components, as I previously say, and data source for these components just represent some configuration for build the query to the Algolia. For example, it includes the number of results that we expect from the Algolia. So it includes some filter by templates. It also includes the text to get relevant data from Algolia. Come on. I'm sorry, my presentation very slow today. In some reason. Okay. Yes. One more important thing that allows us to achieve our main requirement is the performance budget. It defines a page size, which is guarantee that the page will be loaded faster than 1 second. The performance budget of the initially visible components of the page should be less than 750 kilobytes. I need to mention that we utilize a React Dynamics import to make the initial page weight less. Each component represents a separate JavaScript and CSS chunk and is loaded dynamically when the component reaches the visible area. We have implemented a custom workflow state which pass the items through the performance budget validation, and if validation is failed, item cannot be published. So also we can see that we have different requirement for the time. So for the load times, depending of the network where the page is requested. Supporting Sitecore Forms by GSS was announced along with Sitecore 9.3. To be able to use forms, you have to add the Sitecore JSS forms and Sitecore JSS React forms modules to your JSS app. Nothing required from the server side, and it works fine out of the box. We have faced only one issue with the cache of anti-foreign token. This token is unique for each form loading, but we have got it cached, and all form submission were failed. Unfortunately, we didn't find any elegant solution and just excluded the whole page from the Akamai HTML cache. The next thing, which is pretty nice in GSS, it's extensibility, and the most interesting and what easy thing that you can extend it's layout service context. So we can compare it with Sitecore context in original.NET Sitecore solution in the CMIN, and it includes some context data like site, language, state, and editing mode and other things. But we use it to also to keep some configuration data. We can see that we add some tokens for Algolia, for Google API. So there was a question about security, and but anyway, so all these keys will be used by JavaScript, and you can store it anyway. But if you can reach it by JavaScript, everybody can read it anyway. You can easily provided by JavaScript by layout service. There's nothing unexpected. Also, we extend our context with some breadcrumbs stuff and alternative URLs. It is something which is common for whole page. It is not related for some specific components. All components can use this data. There are two ways to define how rendering and associated data are serialized. Oh, sorry. A serialized rendering content resolver. It can two ways. So it can be rendering content resolver and component GraphQL query. So, for example, we have a JSON rendering, which I created for the demo. It is component with default rendering content resolver, which serializes a data source item if it's set for the components on the page. So we add the component to the page and choose previously. So we have it. I created a template for the demo, which includes 3 fields: title, description, and image. And then I create some item as a data source based on this template. Then I added the component to the page and choose this data source for this item. Actually, in layout service, I got this component serialized with data from our data source. We can see the 3 fields here: title, description, image. Then I want to do the same with GraphQL query, and we can see that I extended with some additional data. Previous example include just the data source part, where I get data source and context item at the as in input parameters to the function. Then I reach this item and read fields from data source. In addition, I add to the JSON to our response the title from the context item. And another thing which we utilize for our components, it's a dictionary. We don't use the original dictionary service just to avoid an unexpected data coming from server. We just built a custom structure where we put all component related dictionary to the folder and then just retrieve it by pass. And finally, our JSON looks like on the image. We can see data source still pretty the same. We have additional level here like a GSS. GSS is a function which will automatically recognize if it's editing mode, and if it is, it also add some editable stuff here to be able build some experience editor stuff. Then we can see the context page item title for the context page, and then we can see list of dictionaries where we have only one dictionary here. And then I tried to do the same with rendering content resolver. I implemented custom rendering resolver, and the code looks like on the image. So we need to have some field IDs or field names. We need to get data from the field. Then we need to check if it's experience editor mode or not. If it's experience editor, we need to add additional data here. Then, sorry, I always forgot that it's not Visual Studio. And then if it's not experience editor, we just respond the values. And in this example, I didn't get the dictionary, so we can add one more section and some more code for retrieve the dictionary. Then you need to build your solution. You need to deploy the assembly to the web root and wait until application pool will be recycled. In my point of view, the utilizing the GraphQL looks much more flexible and faster, but you always need to be careful about the template naming. It doesn't like, so I mean the GraphQL doesn't like the templates with the same name. It always adds some GUID under the template name, so it's not very useful, but it is better if you will try to keep your template's name is unique, even between the different websites. A few extensions that we implemented for our GraphQL. We added some site-specific item query. It allows us to request items by relative passes. By default, GraphQL doesn't know how to do that. Actually, you can just use the full item pass to get it. But in our case, we have a few different websites, and we have some configuration. We have the same structure for the websites, and all sites have the same configurations, but different values for that. And we use the relative passes to get some settings. The same thing that we customize, it is search query. The search works fine out of the box, but it doesn't know how to search and cannot search by ID. It is required for us. We get some, so the parameters like context item and data source item, which is showed on previous images, includes the IDs. And if you want to find some items under the current item, you have only one thing, is use the context item parameter, but it includes an item ID, but GraphQL cannot search by item ID by default. So we customize this logic. Another thing is item resolving process or standard Sitecore solution has the processor item resolver, which you can always override. You can add your own custom item resolvers, and you have to put it to HTML request begin pipeline. But in case of using layout service, you also need to implement additional custom item resolver and put it to the MVC request begin section pipeline. It is also important thing because sometimes we get some misunderstanding why when I put the URL to the browser, I get the correct item, but when I try to retrieve this item from layout service, I get 44 error, for example, because the item cannot be found because the layout service item resolver is not overridden with necessary logic. Also, very simple thing that GSS cannot do by default. At least I don't know if it's fixed or maybe implemented in Sitecore 10, but previously it was not working with virtual directories. For example, we have site A with website com domain, and we have a site B with some virtual directory. It's pretty different websites, but they use the same domain and different virtual directories. And when you just try to request the homepage with website from the website com, it will work fine. But if you will add the virtual directory to the layout service request, it will response the 44 error because layout service doesn't resolve the virtual directory by default. We also have to override some item resolver processor to make it possible. Another thing is that there is some problems and some issues to work with global content. As I showed at the beginning of presentation, we have some global content, and when we try to retrieve the page, and so we use the build card items to understand as a starting point for our website to search some dynamic some global content, and then we override the item resolver and try to replace the context item with the item from global data folder, and then GSS tries to resolve, in this case, GSS up template, and by default it just gets the item path and try to find root item and try to find then configuration for the GSS app. As our global folder is not a site, it definitely doesn't have GSS app configured, and it always fails. And we have override this processor that you on the screen to make it possible working with global content. And probably last thing that I want to say is probably the main issue that we faced is the communication between front-end and back-end developers. Actually, our customer decided to use to work with different and separate vendors to do the backend and front-end. Actually, our company do just backend stuff, and another company did the front-end. The front-end guys was coming and to join us a few months later, and probably almost all contracts were done before they come to the project. But the contracts were done from our perspective, so from our point of view, and it doesn't mean that front-end developers has the same view, and it raised a lot of changes and misunderstandings and communications. It was difficult because it's difficult when front-end developer doesn't know how experience editor works with Sitecore, and I can't imagine how the front-end developer who never worked with Sitecore previously can build the page and support the experience editor. So it's, in my point of view, it's impossible. But after the few months, we have our front-end developers had some background in Sitecore, and the things become easy. But at the beginning, it was very, very difficult. So the communication is very, very important thing in their GSS projects. And probably that's all from my side. Thank you for attention.
Well, thank you, Artsem. We just have 3 minutes. If anyone has any questions.
Yeah, I have one question, maybe two.
Okay.
Well, first of all, thank you, Artsem, for such a deep dive on your question. And I always thought that Brimit guys can talk forever about their solutions. Question is Sitecore first or code first approach. Did you come up with that by your own, or is it something well known?
So we had a lot of templates. We have a lot of pages, and was really impossible to do from the code first, actually. So the content editors become working much more early than templates, all components were done. So there is very difficult to work with code first. It's really for small single page applications, probably for campaign websites, but it's very difficult for the project that we're working almost for a year.
Right. Like second question, I mean, I'm not the GSS guy, I'm not the front ender, but this Akamai cache, is there any alternative to Akamai cache? Did you consider any alternatives to Akamai?
To use the Akamai was a decision of consultancy agency that our customer works with before started the project, and actually we didn't do this choice. Actually, I have never worked with another cache engines.
Okay, but it sounds like you are satisfied with how it works, right?
Yeah, so our client, our client was using Akamai previous with Sitecore 7, and they did a lot of on the Akamai side. But yes, it's a very powerful tool. Actually, yeah, I satisfied definitely. I don't know how much it costs, but I think a lot.
Okay. Thank you.
Welcome.
Okay. Great. Thank you. Yeah, thank you so much.